All right, here we go for problem one. We're just basically looking at combining a couple of fractions. Well, the first thing we got to do is be able to actually get these fractions together, right? So we're going to make some kind of common denominator. So between 4 and 7, it has to be 28. So I know that those both have to be 28 as far as the denominator. So then to get that up to, that would have to be then 7 28s, multiply that one by 4. So this has to be minus 4 28s. Which then the denominator would just become 3 28ths, right? So 3 over 28 is the total denominator, and our numerator is 2/3. So what does that mean? That means I'm taking 2/3. So I'm taking 2/3 and I'm dividing it by 3 over 28, or I'm multiplying by 28 over 3. And let's see, can I simplify that at all? No, I can't. So that's just going to end up being then what, 56 over 9. So that would be 56 over 9. And we're going to add 2 to that. So we got to add 2, which 2 in this case, if it's 9, would be 18 over 9. So this one then should be what, 74? So it should be 74 over 9. And so that's what our answer there should be. Okay, moving on to problem number 2 here. Well, we know 8 2/3. Well, that's 8 2/3 power. So that's the same exact thing as saying 8 squared and cube root, right? So this would be then that, so 8 squared. Or I could say the cube root, or I could say the cube root of 8, quantity squared. Well, the cube root of 8 is 2. So 2 squared is 4. And there's our answer there. Okay, with the next problem, we're going to actually look at 2 different components. Well, I can see I have a half and a 3/2. So since this is all multiplication, but even though I can kind of ignore this negative 2/3, well, what is 1/2 divided by 3/2? So that'd be multiplied by 2 over 3. So that just becomes then 1/3, right? So I can say that that part is 1/3. Well, 2x plus 5 to the negative 2/3. We know negative exponents just cause it to flip. So then that would become 2x plus 5 to the 2/3 power in the denominator. And we're going to have, then this is going to be a 3 because this would be 1/3. And there's our answer there, and that's all we can do. Okay, this problem here is very similar to our first problem, where the very first thing we got to do is figure out how do we make this, because I can't divide these out, I can't simplify these out until I make them into a common denominator. So this 25 over a is going to be 25 over a, and then we got to make this a denominator of a. So how would I make the denominator of a? Well, that would be a squared over a. And then this is going to then be 5 plus a. Okay, well, let's see. What does that look like to us? So remember, let's think about what is a squared minus 25. So we know I can do something with that. So let's think about what that may be. So right now I have 25 minus a squared over a divided by 5 plus a. Well, instead of 25 minus a squared, I'm going to take that negative out. So I'm essentially going to divide both of these by the negative and make that negative 25 plus a squared divided by a. And then we have the rest of it divided by a divided by 5 plus a. Okay, well, what does that tell me? Well, I can factor that. That's going to see, I got a plus 5, a minus 5, divided by a, and then it says divided by 5 plus a. We know that would be then multiplied by 1. So instead of divided by, this would be, so let's put that over here. So technically I have a plus 5, I have a minus 5, and divided by a. And instead of dividing by 5 plus a, I know I'm multiplying by 1 over a plus 5. Well, what happens to the a plus 5s? Well, you should see that those cancel out, right? So the a plus 5 cancels out the a plus 5. And so my answer is just a minus 5 divided by a. And that is all we can do. I just about forgot we did divide the negative out. So when we divided the negative out, the negative should also be there. So I could also write that as 5 minus a divided by a. So that would be the exact same thing between the two. Those two are identical. All right, for number 5 here, what we first want to look at is we got x squared and x to the minus 3. Well, what do they both have in common, or what's the lowest that they both have in common? So technically I can take out an x to the minus 3 out of both of them. Okay? And what does that leave? So in other words, if you take out x squared and I'm dividing that by x to the minus 3, well, that negative would come up, and that would leave me, in that case, that would leave me x to the 5th. Okay, so far so good. All right, so let's see. Now, what about the other component? Let's see, x plus 2 to the minus 1/2 and x plus 2 to the 1/2. Well, the lowest component of that would be x plus 2 to the negative 1/2. So I'm going to take that out of both. And what does that now leave me? What's the leftover terms? So in this first group, x squared divided by x to the minus 3 leaves me x to the 5th. And x plus 2 to the negative half divided by x plus 2 to the negative half just becomes 1, so that goes away. And then I have minus, well, x to the negative 3rd divided by x to the negative 3rd is 1, so I don't ignore that. Well, the x plus 2 to the 1/2 divided by x plus 2 to the negative 1/2. So I'm just going to look at essentially as if it's x to the 1/2 divided by x to the negative 1/2. And that negative 1/2 would come up as 1/2. And 1/2 plus 1/2 is just 1. So that just gives me this x. Or that would just give me, in that case, just x plus 2 to the 1st power. Well, can I do anything else with that? Nope. That is as far as you can go, and that is factored completely. Alright, so the only other thing we had to do here was eliminate the negative exponents. So negative exponents we know, so I can just move these to the denominator. So in other words, we're going to have x to the 5th minus x minus 2 divided by x cubed times x plus 2. Oops. X plus 2 to the 1/2 power. And that is our final answer, eliminating the negative exponents, factoring completely, and simplifying. Alright, 6 is really pretty easy here. All you're really doing is just plugging in negative 3 into the g function, so you would have 2 times negative 3 squared minus 1, well that would just be 2 times 9 minus 1, or 18, or that would be 17. So we're just plugging 17 into the f function, or 2 times 17 plus 1, so that would be 34 plus 1, or answer here is 35, and that's all she wrote on that one. Alright, this one now we know we're just putting t plus 2 into the x squared function, so we just have 2 times t plus 2 squared minus 1, and that would just be 2 times t squared plus 4t plus 4 minus 1, distribute out, so that would be 2t squared plus 8t plus 8, but 8 minus 1 would be 7, and so there's our answer there. Nice and easy. Alright, for 8 you're basically doing the problem twice, so we have f of x plus h minus f of x. So the first thing we got to do is put x plus h into x, so then this would be 2 times x plus h plus 1. So that would be just this first part. So that would give us 2x plus 2h plus 1. And then we're going to subtract. Now I'm going to subtract the other part, right? So subtract them, or minus f of x. So now I'm going to minus the 2x plus 1. And then divide all those by h. Well, what does that give me? Well, I know the 2x minus the 2x, that goes away. 1 minus 1, that goes away. So, in this case, you just have 2h divided by h, which the h's divide out and just gives me 2. And that would be it. Okay, this one really, the only word that really matters on this, or the only word that makes it a little bit tricky, is a word we don't really see that very often, normal. Normal means the same thing as perpendicular. So the first thing, let's just figure out what does this equation look like. So if I move the 2x over and the 3 over, so let's move our 3 over and move our 2x over. So I have negative 4y equals negative 2x minus 3. Divide all of it by 4, by negative 4. Right? And I have my equation of my line, y equals, and this would be 1/2 x plus 3/4. And we want to know what's perpendicular, so we're looking for something with a slope of 2. Okay, and we have a point, so let's just put it in point slope. So I could say, well, that would be then y minus 3/2 equals 2, x plus 125. And that's really all you got to do. Nice and easy. Alright, to find the period of an equation, and so anytime you want to find the period of any given equation, it's just always 2 pi divided by k, where k is whatever is combined with the x. So in this case, pi, or 1/9. Okay, so, or pi over 9. So let's do 2 pi, then over pi divided by 9. So what is 2 pi divided by pi ninths? Well, that would be then 2 pi times 9 over pi. So that would give me then, this would be a period of 18. No pi's, the pi's divide out, and that would be it. That would be a fundamental period of 18 for that particular equation. Fun times! Alright, so the first thing when we're trying to figure out in graph is we need to always be able to figure out what is our period in this case. So if I take my period and it's 2 pi divided by 1/2, so 2 pi divided by 1/2, so I know that's going to be a period of 4 pi. Okay, so that means that it's going to make my full cycle, so it's going to take the full cycle to go from the start all the way through the whole wave would be 4 pi. Or in other words, all the way around the whole circle would be 4 pi. So from start to finish. So in other words, we've got just a bigger circle. Okay? So, and then the 3 would affect the amplitude, the negative. So let's think about cosine. Well, cosine normally starts. So let's talk about what let's first think about the circle, what our components would be. So if it's all the way around is 4 pi, that would mean this would have to be pi, this would have to be 2 pi, this would have to be 3 pi, and this would have to be 4 pi. But we were confining it to 0, so we're confining it between 2 pi and, so let's see, let's call this first one, let's call that pi. Let's call this next one 2 pi. So that whole then cycle would be 4 pi. Okay, well, let's think about what would it look like if it was just if that was just a 0. So we know, and let's call this 1. Let's call this up here, so every 1 goes. So that'd be 2, that'd be 3. So up here is 3. This is -1, -2, -3. So that's -3. And once again, this first one is pi. The second one would be 2 pi. And I could go farther out and make it 3 pi. and make it 4 pi. So I can make that last one 4 pi if I wanted to. Alright, normally cosine, we know, would start at 0. So cosine at 0 normally starts up at the top, or whatever the amplitude is, and then would go down and then back up. Right, well, this one's going to have an amplitude of 3, but it's a negative, so instead of starting at amplitude of 3, it's going to start at here at negative 3. And instead of going down, it's going to go up. So it would be here at 0, and then it would be back up. And since we're only going between negative 2 pi and 2 pi, then it would be the opposite on the other side. So it would be here, and it would be here. And the only other thing we got to do is see what happens when we add the negative 1. Well, the negative 1 is just going to shift everything down 1. So that would mean it would go down to negative 4. And instead of being at 0, it would be at 1. So then our graph would be at negative 1. And then it would be here. And so we would end up getting our graph that looks exactly like that. And this is terribly drawn, but you get the idea. So the 3 affects our amplitude, so that tells me how high or above our 0 point, right, does it go. The negative would cause it to flip upside down, just like all transformations. The 1/2 only affects our period, so normally this would go, it would start at 0, it would go to pi, it would go to 2 pi, it would be back to 0 for 3 pi, and then back down. And so that would be our cosine wave, would look like that. However, we have this negative 1 that shifted everything down. So there's our graph. That's exactly the graph of this function. Alright, so let's look at a couple of things in this one. It asked me for give the coordinates of the x and y intercept. Well, we know the y-intercept occurs when x is 0. So if this is 0, so 0 minus 3 cubed. So let's see, if x is 0, so I got negative 2x minus, so that'd be 0. So I have negative 3 cubed, and then plus 2. So let's see, what would that be when x is 0? Well, notice negative 3 cubed. Well, it'd be negative 3 times negative 3 times negative 3. So that'd be negative 2 times negative 27 plus 2. Right? So when x is 0, y is really, really, really big. So that would be 54 plus 2. So my y-intercept in this case has got to be when x is 0, y is 56. So way up there. Alright? So let's see. And we know a couple things about cubes as far as graphing is concerned. When I go to graph cubes, I know that it has to be, so standard cube would look like something like this. Would be our standard cube, somewhere in that neighborhood, right? Let's see, we can think about a couple of transformations then. So if I just want to do just transformations, standard cube would be 0, when it's 1, it's 1. So if I was just graphing y equals x cubed, that's the easiest way I think to graph. So I could take my chart x, y, so when x is 0, y is 0, when x is 1, y is 1, and we're just looking at, once again, y equals x cubed. When x is 2, y would be, so 2 cubed would be 8. When x is 3, So 3 cubed would be 27. So there's a couple of things, and we could go backwards when x is -1. So there's our standard, and we could look at, then we could think about what transformations may do to that. All right, now, so if I want to talk about transformations, I can look and see what does that transform to, right? So we know that the -3 would move it to the right. So instead of being, so everything's going to move, so all of my x values are going to go right 3. So instead of being at 0, this would be 3. Instead of being 1, this would be 4. Instead of being, and so forth and so on, right? So you can see that concept, right? So the -2 would then also affect my y. So instead of being, so I'd multiply all these. So instead of being 0, it'd still be 0. Instead of being 1, it'd be -2. Instead of being 8, it would be -16. And then we would add 2 to all these values. So when it's -3, so you can see all of these pieces, right? So that would be our way that we could go ahead and graph this out. So instead of at 5, we'd add 3 to it. This would be 6. Multiply this by -2, so this would be -54. Let's add 2, so this would be at 2. This would be at 1, and this would be 0, and this would be 54, but add 2 to make it, so 54, this would be 16, and this would be at 2. And then the last thing we got to do is do our last transformation, so add 2 to these, so we add 2 to everything, and now I can plot all the points, right? So nice and easy. So this would be 0, this would be 14, this would be -14, -52, this would be 4, and so I can plot these out. So when x is 3, y is 2, when x is 4, y is 0, when x is 5, it's -14, so way down here somewhere. And I'll need 6, so when x is 2, it's at 4. When x is 1, I didn't add 2 to that, so that'd be 18. So when x is at 1, it's way up there at 18. And I can see that would be then my graph that would look something like that. Really kind of steep, going down like that. And then I know we set our x-intercept, so I can see my x-intercept would occur right here at 4, 0. So this would be 4, 0. My y-intercept would occur, like I said, at 56, right? And there we go, there's all our points that we needed. Alright, so when we're working with trig functions, I always go back to the unit circle. So the first thing we got to figure out is, what I like to figure out at least, is where is 4 pi over 3 as far as what quadrant it is in. Well, 4 over 3 I know would be right down here somewhere in quadrant 3. So that means that the x is negative and the y is negative. So since it's a 3 on the bottom, I know that this has got to be, the coordinates is going to be 1/2 and square root 3 over 2. Since it's quadrant 3, they're both negative. Well, we're looking for the sine value. So sine, we're looking for just the y value. So this one is just negative square root 3 over 2. And that is all she wrote. Alright, so cotangent of -7 pi over 2. So let's first figure out where is 7 over 2. Well, 7 over 2 is this thing, so let's just divide that out. So 7 divided by 2 would be what? That's 3 1/2, right? So that'd be 3 1/2. So that'd be the same thing as 3 pi and an extra half of a pi. Well, if I think about that as 2, so I'd be going around the circle, so going backwards. So that'd be going, there'd be 2. And then I got to go another 1 1/2. So there's 1 1/2. So it'd be the same value, exactly the same value as cotangent of pi over 2. So that's the same exact spot. Well, let's see, what is pi over 2? So we know at pi over 2, so I know if I'm up there, once again, if I go around the circle, we're going the negative direction, so I'm going that way. This would be going around, that'd be twice, and then I got to go around 1 1/2 more times. Alright, because that would be then 2, that would be 3 1/2. Okay, so that'd be right there, that's what we said, right there at pi over 2. Right there I know that value is 0 and 1. Well, what is cotangent? Cotangent is the opposite of tangent. So since tangent is y over x, cotangent has to be x over y. So I'm taking x divided by y. So x divided by y, 0 divided by 1 is 0. Alright, so when we're going with logs, the very first thing we've got to do is be able to simplify this into one log expression. And we know subtraction is the same thing as division, so if I condense this down, this would be the same as saying log of 7 of 2x squared divided by x. So I can simplify that to say that, well, that's just log base 7 of 2x. So that's equal to 2. And I know that getting out of log is the same as base to the y equals x. So that means 7 squared has to equal the 2x. So therefore 49 has to equal 2x. And x has to equal 49 divided by 2.